Hi, madam. My name is Stephen Daniel from class DOL2. Today, me and our group mates would like to present about matrix. First, I want to talk about definition of matrix. A matrix is a rectangular array of elements appear in rows and columns, usually enclosed by brackets. Each matrix is called an element, and the position of n elements is identified by its row number and column number. Element in row and column are and can be written as AIR. For example, in the matrix A equal to in bracket 2, 1, 6, and 3 in bracket. So this example of matrix. The element A11 equal to 2 refers to the entry in the first row and the first column, while A21, which is number of 1, refers to the element in the second row and the first column. The size of order of matrix is described by the number of rows and columns it contains. For instance, the matrix above has 2 rows and 2 columns, so its order 2x2. A particular important type of matrix is the square matrix, which has the same number of rows and columns, often written of order n x n. Square matrices have several unique properties that distinguish them from other matrices. Firstly, the number of rows is equal to the number of columns. Secondly, a square matrix always has a main diagonal, which is the set of elements that run from the top left corner to the bottom right corner. To illustrate 2x2 square matrix can be written as B equal to in bracket A, B, C, and D in bracket. So where the elements A, B, C, and D, similarly a 3x3 square matrix is written as C equal to in bracket 2, 1, 7, 4, 3, 8, 6, 5, 0. So this is equal 3x3 square matrix. Thank you. I would like to pass for our next group mates, which is Nazrul Amirul, for explain about our question 1. There is a problem. Thank you.
My name is Nazrul Amirul Madihi. I am from DOL2. Today, I want to explain about question 1. After we get information from the question, then convert it to equation. Then after that, we convert it to the matrix. After we convert to matrix, then we calculate it for 2 determinants. First determinant, we calculate it and get answer for negative 11. After that, we go to determine. Fuck, man. So that we calculate it to the determinant. After we calculate it, that we get the answer for negative 11. Then we go to determinant x. We calculate it again, then we get it negative 1, 3, 2. After that, we go to determinant y. We calculate it again and get the answer for negative 9, 9. After we get all the answer for determinant, then we get the answer for x. So to get the answer for x, determinant x divide to determinant, then we get 12 for set with ring. For y, we do it same. We calculate it, then get for 9 without ring. That's all for question 1. And for question 2, we go to Aisha. Okay, thank you.
Hello, today we are going to solve a 3x3 system of equation using inversion methods. So this is the linear equation that I got from question 1b. So firstly, we need to convert these linear equations to matrix form, like so. And then we are going to name each matrix. This is A, this is X, this is B. So this one is the, how do you do it? So in this situation, we want to find the X. So in order to find the X, we need to find the inversion of A, and then we times to B. So on to the first step of using inversion method. So we need to find the determinant of A. So firstly, how do I get this number in front of this? According to the formula, you need to use the first row number. 2, -1, and 3. As you can see, 2, -1, and 3. And according to the formula, you need to use this formula first, plus, minus, and plus. And how do I get this? You use this determinant formula, which is AD minus BC. So, for the first one, 2, 3 times 5 minus -2 times -1. There you go. And then the final answer for this determinant A is 9. So, cofactor. Firstly, it's the same as this one, plus, minus, plus. That's just the formula. You need to, it could follow the formula. So, plus, minus, plus, minus, plus, minus, plus, minus, plus. So, how do I get the number inside? So, as the first row, first column, you need to hide this one. You hide first column, and then the first row, and then you get this number, 3, -1, -2, and 5. And then you solved it by using AD minus BC. 3 times 5 minus -1 times -2. And then there you go, you got the answer for each one, right? So now, once you've gotten the answer for cofactor, you go to adjoint. What does this adjoint mean? It means it's the transpose of cofactor. How do we do it? Cofactor of transpose of cofactor. The column becomes row, row becomes column. So this one we put here, this one there. So that's your final answer for adjoint. So next one, you do the inverse matrix. The formula is here, 1 over determinant times adjoint. And then you put all the value that you have gotten before. You just put it inside. And then you solved it using your matrix knowledge. Then there you go, boom. 1 over 9 in the bracket, -9, 45, 27. Then 1 over 9 times -9, you get -1. 1 over 9 times 45, you get 5. 1 over 9 times 27, you got 3. So that's our final answer. X equals to -1, Y equals to 5, Z equals to 3. Simple as that. Thank you. Then I'm going to pass on the next question to Sharif Al-Idrus.
My name is Sharif Al-Idrus, and I'm the last of the representative of our group that would be presenting on this topic of matrix. Question number 1, question C. All right. Before we get started, I would like to state the question is prove in bracket AB times C equals to A inside the bracket BC. So in this question, it doesn't specify what type of matrices that we should use in order to prove this statement. So I went and choose 2 by 2 matrices. Okay? Alright. It is quite a simple question. It's really straightforward. For the first step is I do the in bracket AB times C. So I did just that, and I had to multiply it a couple of times. Firstly, I have to multiply A and B, then I have to multiply it with C, then I finally got the final answer. So for the matrices that I use, for A, I use 2, 4, 0, 1. For B, I use 1, 4, 2, 4. And for C, 9, 5, 4, 2. And as you can see, for AB times C, the final answer is 186, 98, 34, and 18. Alright, now we move to the second part of the question is A times in the bracket of BC. Pretty similar, but pretty similar steps that we will do, just like the previous one. But this one is a little bit different because right now, at first, we're going to multiply matrix B and matrix C. And then, after we're done multiplying it, then we can multiply the product with A. So the product is 2, 5, 13, 34, 18. Then we can multiply with matrix A. And after that, we finally got the same answer, which is 186, 98, 34, and 18. So, this statement, prove AB times C equals A times BC, is in fact correct. And it has been proven with simple calculation using simple operations. So, as for the conclusion, we as a group has come to a conclusion that the importance of matrices can be seen in wide range of fields that rely on them, such as technology, economics, medicine, transportation, and engineering. They are used in solving simultaneous equations, representing complex networks, and organizing massive amounts of data in a systematic way. By arranging numbers in an orderly format, matrices make it possible to simplify difficult problems and speed up processes that would otherwise take a lot of time and effort. This shows that matrices are not only mathematical concepts studied in classrooms, but also a practical tool that has shaped the modern life and make problem solving more effective and efficient. Alright, that is all from us. Thank you, Madam Azhani.